So the next effect that we're going to look at is pH effects. And one thing that we can definitely say about the pH effect is the pH has a very, very, very large impact on solubility of a salt in solution. So this is what we're going to say about pH. The pH of a solution will affect the solubility of any substance whose anion is basic. So the first question you say, but Dr. Fuss, what are the basic anions and what are the neutral anions? So this comes back to memorizing and knowing exactly what these strong acids and strong bases are and how their conjugates are going to come into play with this. So we need to know what the basic anions are. And if we remember from acids and bases, if you have a strong acid, you're going to have a neutral conjugate base. So the anions that we need to look at, first we can eliminate all the neutral anions. So let's list those. We have a list of neutral anions, which if you look in your lab manual on page 34, it will list them out for you. The neutral anions come from all of the strong acids. There are 7 strong acids. So the neutral anions are going to be Cl minus, Br minus, I minus, ClO3 minus, ClO4 minus, NO3 minus, and SO4 2 minus. In addition, since H2SO4 is a diprotic acid, we can also consider HSO4 minus to be a neutral anion. So these are the neutral anions, and from this we can consider all other anions to be basic, because they're going to be the conjugate base of a weak acid. So if we look at the statement from the lab manual, and the statement that we're going to observe is that salts containing these anions do not become more soluble as we lower the pH. And when I say these anions, I should say the neutral ones. So the neutral anions are really not going to have, or they're not really going to be affected by an H+ in solution. Because remember, when you have an acid in solution, it will neutralize a base. It doesn't matter what the identity is of that. If we have an acid and a base, there's going to be a neutralization reaction that is going to occur.